In the previous video, we have seen the factory I/O designing of Palletizer machine, which is this one. So in this video, we are going to see its ladder programming and understand each and every network step by step. If you don't know how to create the project in the TIA portal and how to link it with factory I/O, please watch the beginning of this series 2 or 3 videos where I have shown each step in detail. So here I have already created a project. I have copy pasted the sample function block file for linking with factory I/O and enabled that function block over here. We have to enable the function block like this. And I compiled, download my project in the PLC sim. I kept it run. Then in the factory I/O drivers, connected my TIA portal. This is how I connected my input and output sensors. So I am going to use start stop button, palletizer, elevator back and front limit to detect the presence of pallet. This is capacitive sensor 0 for counting the box and then move pusher. This is capacitive sensor for elevator up limit, and I am going to use this feedback, palletizer clamp feedback and palletizer plate limit. Okay, some of the things I'm not going to use over here, but I have connected all my inputs like this. Important thing to observe over here is my inputs are starting from I 5.0. This is necessary because when we keep it 0.0 or same as the physical address of the PLC, sometimes factory I/O malfunctions. So it is advised to offset this address. How you can change this? So in the configuration, you can offset address from here, and this is the number of inputs you want. Similarly for outputs and the analog input output. Right now, I just change this one. So here I have connected my outputs. It is necessary that you also connect the outputs like me only. For example, if I connect roller conveyor at Q0.0, then your output should be same like this. So after that, I have used elevator chain minus. Okay, palletizer elevator chain, that is, which will stack the pallet. And after this, elevator plus means elevator up, elevator down, pusher, clamp. This is belt plus only, and open the plate. This is the exit conveyor. Okay, this is the belt conveyor for boxes which is over above, and this is the exit conveyor. Okay, so this is my driver details. So first network I already told you. So quickly moving to the other networks. So my next network is start stop the system. So as soon as I press this start button, I have to ideally we use memory bits for such operations, but as I already told you, my memory bits are not working well with factory I/O. So I have taken one spare output which I'm not going to actually use, that is my Q10.0 as my system on indicator. And when the stop button is pressed, because this is the NC, okay, right now it is not pressed, so its signal is coming. Signal is coming means it's NO. If I take NO of 5.1, it will be giving me signal. For example, if I press this, you can observe. Okay, let me start the simulation first. When I press this, I need to go closer. Now you can see when I press this in the 5.1, we are observing continuity because this NC is cut off. So signal at 5.1 is turned off. Signal of 5.1 is turned off. That's why its NC is on right now. This is the thing happens in real life scenario if you use NC stop button. Right now, because it's NC, its signal is coming. Its signal is coming. That's my NO contact of 5.1 will be on. Okay, this thing you have to understand. So when I press this button, what should happen? It should reset all my outputs and memory bits, and also this my system on indicator. Now how I am resetting all the outputs in one line only. So here in the instructions, in the bit instruction, you will get reset bit field. So by mentioning the starting address and the number of outputs from the starting address means 11 outputs starting from Q0.0 will be resetted. Similarly, same for the memory bits. 24 memory bits starting from M0.0 will be resetted just by writing this single line. So this is how I am going to start and stop my system. So if my this bit is on, then my other operations will be performed. Okay, let me minimize this. Now from here, two operations are going to happen simultaneously. This pallet will loaded over here and elevator will move up. That is one part, and boxes will come from here and it will stack boxes over here. That is another part. This both process will happen simultaneously. So first we will understand the loading of this pallet. Okay, so I'm starting the third network, that is load empty pallet in the machine. So for that you can observe this network. First condition is system should be on. When I press this button, system will be on. Now you can see there are the two proximity sensors over here. These blue dots you can see, these are two sensors. Right now sensors are off. That means its NCs will have on. Okay, because sensor is off, it NC will be on. So I want to detect there should be no box. I mean there should be no pallet over here. So because there is no pallet, its NCs are on. If there is no pallet, then only this will conveyor will start. And this there should be no pallet for 2 seconds. So while unloading the box or pallet over here, it may happen the pallet just reached to this point and both sensor will be turned off, so it will start the conveyor. So this condition should be remained for 2 seconds. Then my pallet loader, this conveyor will start, and here this output palletizer chain minus, it will also set. So my pallet will move in this direction. Okay, and when the timing is completed, it will reset the timer. Now because I am using the set, I also have to reset this conveyor. So how I will do that? So first let me show you the set part. Okay, so now because 2 seconds completed, it will set it. Okay, now let me stop this and start from the beginning. I'm stopping this. Now this was about set part. Now how it will be resetted? So it is simple. When these two sensors are turned on, this both chain and conveyor will be resetted. So again let me show you. Or after 2 seconds it start. You can see these are start. When both sensors will come, it will reset. Okay. You can see this is turned off because there is some delay, but outputs are turned off. Otherwise the pallet would have fallen from here. So this is how I resetted chain and the conveyor. So this was about loading the empty pallet. Now again I will stop this because I want to explain you the logic step by step, network by network. Okay, that's why it will take much time, but you will understand properly. So we have understood 4 networks. Now I want to move elevator up. Okay, and this is a little bit lengthier network. So the first condition is system should on and the pallet should be loaded, means both sensors are on. Then our process of elevator up starts. Up to when this output I want to start, but up to what time it will remain start. Okay, in the previous video I have shown you, if I turn on this output and elevator up, these two outputs simultaneously, my elevator will move smoothly upwards. But because it was malfunctioning, I have to use one timer to on off this output. First on it, then off it, on it, then off it. So in the steps, my elevator will move upwards. Up to what extent it will go? So this is the sensor. You can see this one, this sensor. So when this sensor is on, means its NC will be gone. So at that time, this output will not turn on again. Now I have used this memory bits. So what are these memory bits? This is memory bit for elevator move down. So when the elevator is moving down, this logic should not work. This is a memory bit of counting, means when I auto processing, 3 layers will be stacked. So until that process is completed, it should not move up. And this is opening plate memory bit. So while opening plate, elevator should not move up. These are the interlocks I have taken. So initially when you are writing program for the first time, you don't know which memory bits you want to take. So how I write the program step by step, means first this part, then upward, and then cycle part. So wherever I am feeling malfunctioning is happening, so I take the interlock of that memory bit over here. Means, for example, I was moving my elevator down. At that time also, my elevator up output was getting on due to some reasons. So what I have taken the interlock of that over here, like NC block. If this process is happening, this output should not be turned off. So these things, either you try my logic, copy paste it, or you understand this process. Okay, in the previous video I explained you the process step by step what is happening, and you try to write by yourself. And when you feel the malfunction, means elevator is moving upwards when you don't require, so you have to observe what are the process taking at that time, and you have to take the interlocks. While this is process, elevator should not move on. While this process is happening, elevator should not move on. And in this way, you can decide your interlocks. Okay. Again, I am maximizing this window to explain you fully. So you can see the full network over here. System should be on. Both sensors should be on so that the pallet is available over here. When the pallet is available, what I will do, I will take NC of this timer, this timer itself. So because the timer is off, its NC will be on. Okay. And what I am doing, I'm starting simulation over here. I am minimizing this. So it will start because this process is off. This turned on for one time. Again, I have taken, when the timer will turn on, it will cut off this timer. So this NO block over here and NC block over here, what it makes my output on off like that. Okay. Because now elevator is move up to this limit over here, because this sensor is turned on now. So it will not turn on again, but this timer you can see it keeps on off. So this is this NC block and this NO block and this timer, it is making logic like on off. Okay. And because my elevator up is achieved, now outputs is permanently off. Okay, let me show you again in this way. Let me stop this first from here. Now observe over here, when this output is turned on, it will become yellow. So you will see it is blinking, means on off like that. Observe carefully this one. You can see it's on off, on off, on off, on off up to this position. Okay, this is the logic for elevator up. Now we will move to the next part, that is starting of the this conveyor and this conveyor. So let me stop this and we will start from the beginning. When the simulation starts, what happens? So as soon as the system is on, pusher is not working, so that is the interlock. If the pusher is working, belt should not move, and the 1.0 is also the interlock of this pusher. So first of all, if the system is on, belt should be on. And what are these outputs? So if the now when the two boxes are counted, pusher is on. So 1.0, and this is output of pusher. Pusher is on, belt should not move. Okay. Now 1.4 is the number of layer, means until the three layers are completed. When the three layers are completed, 1.4 it will become on. So its NC will be on. So belt will not move at that time. And 1.1 is door opening. Okay, that interlock. So again I told you that I get from when I'm writing step by step. So I get this interlock like this. We will see 1.1, 1.0. I am sure it is for pusher output. Okay, 1.1. This is door open. You see, door are opens. So this bit was on. So when the door are opens and the pusher is working, or the three layers are stacked, belt will not start. Okay, that is the simple logic I have used. Now logic for the pusher. This is again a little complex part. So I have to stop this and I have to explain you the full logic. So for that, let's maximize this. And this is why I tell you it is the advanced level of example. We have to understand it simply. This is one counter, counting up counter. Okay. So what I have, how I am counting, first let's see this line. When the system is on and my sensor is sensing two boxes, means one box pass, so it should count one box. Now again I have taken negative triggering. Okay, why falling edge? Because box should pass through the sensor. Okay, box should pass through this sensor, then counting should be increased. Okay, so I have taken the negative edge. So this thing from the bit logic you can get. Okay, so at the top side I have to give the address of the sensor, and in the bottom I have to give any memory address M0.0 and so on. I will give other addresses. So when this will sense, it will up increase the counter value. And when the two counting is done, means this is my set value. When the two boxes are passed, it will on my palletizer pusher. Okay, now I have to reset my pusher after 2 seconds, means I need some feedback to turn off this pusher. So when the counting is done, it will start the pusher. Simultaneously I will start one timer, and when timing is done, it should reset the pusher. Okay, so when the timing is done, it is resetting the pusher. So I have taken NC block. If the timer becomes on, then next time it will not turn on this pusher again. Okay, because counter has not resetted yet. Timer has resetted the pusher, but still the value of counter will be 2, so it will again set the pusher. So until the counter is resetted, this output will not be off. Now we will see how the counter is resetted. So when this process is completed, I want to go to next process. Okay, once the boxes have achieved, I should again start my process. So to move to the next part, I have taken this M1.0. We have seen this thing over here. So when 1.0, if the pusher is on, our conveyor will be stopped, and move pusher 3 times in one layer. So to go to this part, okay, I have to set one memory bit. Now how this counter is resetted? So that is over here. First of all, if I press the stop button, my counter should be resetted. After that, when the pusher, this output, pusher outputs, means pusher is resetted, pusher will go back. So this is the negative triggering of this output. When this output is turned off, it will reset this counter itself. Okay, and this is the memory bit. I will explain you later words. Means when the 3 layers are stacked, okay, at that time also it should reset. So now, okay, let me turn on this simulation and maximize this. So when one pulse will come, it counted one, and the two boxes will be, it will be on, and after 2 seconds it will be resetted. How it is resetted? Counter is also resetted. Observe this. By this logic, counter will be resetted. You can see this logic activated and counter is resetted to 0, and by this timer, pusher is resetted. Okay, so this is the logic for pusher. Now you want to move pusher 3 times in one layer. Okay, so I have taken another counter. So 1 times the pusher output is on, it will count 1. It is resetted by reset button and 1.3 bit. Okay, what is 1.3? We will understand it later words. Right now, when the 3 counting is done, okay, let me show. When the counter is moved 3 times, right now 2 times moved. When it moves 3 times, what we want to do? We want to clamp box and open the plate. So for that, I have taken 1.1. So by 1.1, I will clamp the box and open the door. Okay. So this is the logic, because I want to move pusher 3 times in one layer. Now how many layers? Okay, before layer, after the pusher has moved 3 times, what we want to do? We want to clamp the box. Okay, this is move 1 time. So in the previous network, I have setted 1.1 memory bit by the counter. Okay, so when the pusher is moved 3 times, this memory bit will be turned on and it will clamp my boxes. Okay, now after clamping, what should happen? These plates, so 1.1 bit is set. Okay, when the clamping is done, plates should be open. and when the plate open limit switch is reached, after 2 seconds, I will reset clamp and 1.2 memory bit. Okay, so what is the 1.2 memory bit? Okay, let me. Okay, so so here I am setting 1.2 memory bit. Okay, again, let us do like this. Let's wait for the next box to come and I will explain you live. When the pallet is clamped, okay, when the pusher is moved 3 times, pallet will be clamped. And when the pallet is clamped, plates will open. And when the plate limit switch, open limit switch is achieved, after some time, I will reset the clamp button and set 1.2. So by counting the 1.2, I am counting that one layer is completed. So how I will close the plates? Okay, let me show you that. When the 1.2 memory bit is setted, after 1 second of that, I will reset the open plate, means plate will be closed. I will reset this output itself and other memory bits that I haven't resetted previously. And this I have taken simple output, not set or reset. So when this output is on, 1.3 will be on, and when this is off, it will off. So by this bit, I am counting the layer. You can see when the layer is completed, this will be on for a while. Okay, because it was 3 layers completed, this bit didn't on. Now we will wait for another one. So this is for resetting. First we setted plates after by the time we set one memory bit, and with this memory bit I want some more delay, and after that delay I will reset my plates and the previous memory bits. You can see it turned on for 1 second. I have setted this 1.3 memory bit from here, and by that memory bit I will count the number of layers. You can see right now there is one layer. Now this second layer will be placed. You can see. So here the counter value will become 2. So this is the counter for when the positive edge of this 1.3 is achieved, it will count. And when the 3 layers are counted, it will start memory bit 1.4. So when the 1.4 is on, belt conveyor will not start, so pusher will not start, and clamping and opening plate will not start. And by 1.4 also I will move the elevator down. When the 3 boxes are achieved, I will move the elevator down. And when this box leaves, I will turn off this. I will reset this counter. Okay. So when the boxes are left by 1.6, this is the memory bit. When the both sensors, okay, let me see how I got this. When the elevator is completely down, so how elevator will come down? That is, let me explain you from here. It is again the advanced network. First of all, there is this timer, which I told you creates logic like on off on off. NO bit over here, timers NO contact over here, and timers NC contact over here. First of all, this is the 1.4, means 3 layers are stacked. So after 1 second, this network will be activated. Now this is the timer, means total 7 seconds. I want this output should remain on. So this is that timer, and this is the on off logic timer. Okay, so 0.5 second on, 0.5 second off, like that. And this is the NC contact, means when this timer is turned off, its NC contact will lose the continuity, so output will not start again. What else I am doing over here? I have taken this 12-second timer for turning on the 1.5 bit. What I will do with this bit, okay, that we have to see over here. So after 12 seconds of this process, means after 12 seconds of this moving down, this is when the stacking is completed. So after 12 seconds of the stacking is completed, I am starting my palletizer chain and exit conveyor to unload the box. And after 5 seconds of it, I will set my 1.6. So 1.6 will reset my counter. Which counter? Okay, let me show you over here. So 1.6 will reset my this counter so that M1.4 is turned off, and M1.4 will, if M1.4 is turned off, then what will happen? M1.4 is turned off, so palletizer belt will start, means boxes will come. Boxes will come, so pusher will move, and pusher will move, so other process will also start simultaneously. Okay, so this is the networks. Right now, we have to see move elevator completely down. So we will see this when this box will come, when the three layers are stacked. And now when the three layers will be stacked, this counter will start this memory bit. By this memory bit, this timer will on after 7 seconds. Until that, this timer will on off this output palletizer down. And after the 12 seconds of it, this bit, you can see it is on off my output. We can see it because it's very low time, and after 7 seconds this will cut off, and 12 seconds, okay, this thing will work. It will start my exit conveyor, and after 5 seconds my exit conveyor also turned off. So this was, okay, let me expand all the networks. So now I will, you can see, pause the video and see the whole network like this. I am scrolling network slowly, so you can see each and every networks. Try to create this by yourself, means first try to create by this copy paste and keep all the memory bits, outputs, inputs, timer values, counter values same. And I will also share the project files so you can check by yourself also. So I am scrolling it down. You can pause the video and see each network, okay, or see the video in slow motion. This is the complete network with comments. Okay, this is definitely an advanced level example, so you have to watch 2 or 3 times properly understand it. Okay, these are the networks, and this is the last network. Here the process will start from beginning. You can see the programming is completed and it's working properly. So friends, I hope you like this video. If you want to see more real life and useful content like this, show your interest by liking and subscribing our YouTube channel. Meet you in the another video with another interesting example.